Bing. Hey, what's up, Dad? This is for my dad. Happy Father's Day. Alright, so I just want to tell you, I'm going to show you what I'm doing here with the hydrogen. Okay, so first of all, I have three things that I'm going to show you right now. I'll show you the very small one right here, which will be this DC power supply. Will be with 2 graphite electrodes, and I'll just dip them in the water, and it will make hydrogen. And then I have this one here, which I bought from China, and I'll show you all about that later. And this is the one right here that I bought off the internet. This one right here will make 11 liters per minute. Crazy amount of gas. Makes a very crazy amount of gas. Okay, so I'm going to show you these just one at a time. Okay, here we go. This is, okay, so I have a DC power supply. Okay, I'm going to turn this on. Okay, so you turn it down, it's at 30 volts, turn it all the way down, and no amps. Okay, so these are actually asymmetrical. These are, I'm going to use 2 that are the same size. Okay, these are each 3 millimeters thick. Okay, so that's 15 volts going through each one of them. Okay, and this is, okay. This is a DC power supply. I don't know if you can see the voltage there. Okay, that's 15 amps. I'm sorry, that's 15 volts. Okay, so we're going to take these 2 electrodes, just little pieces of graphite, and we put them in the water. It's just regular tap water, nothing else on it. Nothing else on it. I don't want them to touch because it'll make an arc underwater. See? Look at that. You can weld underwater. But okay, so that's just a, I'm trying to get these to a point where they don't touch. Damn it. Okay. Put this one out that way. And then this one will be in there that way. Okay, they're not touching. They can't touch. Okay, they're not touching. Here we go. Okay, so that's 15 volts. At 9 amps, at 0.09 amps. You can see it. Okay, so once you look into the that thing. Okay, so we turn it all the way up. Okay, and I don't know. Okay, so I'm gonna just turn it all the way up. Can't hurt nothing. All right, boom. 26. This is 30 volts at 0.21 amps. And I don't know if you can see. I don't know if you can see, but there is bubbles. It's making bubbles. Okay? It's making, oh, and it arcs. You can see it arc. Right, it arcs underwater. But also, if you just don't touch them, right, the bubbles, you can see the bubbles. There's just a lot of bubbles coming out. So basically that's just tap water. And the thing is, if you put, can't really see it. Yeah, well, there we go. That's more stable. But anyway, I just want you to see the damn bubbles. It works. It does work. This is just a little bit, though. This is just not, it's not a lot of power. And it doesn't have sodium hydroxide in it. That's a big deal. Okay. I just want you to see the bubbles. All those bubbles are, oh, now let's turn the fucking amps up. Watch this. Huh, that's as high as it's going to go, actually. Anyway, so I don't know if you can see those bubbles. That is hydrogen. Okay, hydrogen is coming off of this one, and oxygen is coming off of this one. There's twice as much oxygen because it's H one H and two O. I mean, two H's and one O. So the one on the left is hydrogen, the one on the right is oxygen. Okay, and that's just a little something so you can see what it does. And there's, and you can see if you touch these, they will arc underwater. You can weld with them or do whatever you want to do. And as you see, it makes a lot more bubbles too. Makes a lot more stuff. Anyway, that's underwater there. See? All those bubbles are hydrogen. Okay, so we're going to quit with that one. I just wanted to show you that. That's just a very small proof of concept type thing right there. Okay, so we're going to take the electrodes off here. And just turn that off. Okay, so we turn this off. And just water in there. So we just put that over there. It'll dry off real quick. Okay, and this right here is potassium hydroxide. It's very caustic. It's caustic potash. It will eat most things, but not stainless steel. It will eat stainless steel, but it takes a couple years. So this right here, a piece of stainless steel as thick as these, will last for 2 years. It's guaranteed for a year, but they said it'll probably last about 2 years. Okay, so there's that. That's the one I made. This is a pulse width modulator. Hooks up to a car battery. This is meant to run a car. This is meant to run, actually, my van. 5.2 liter van. This will run it. Anyway, I know you don't believe that, but it's all right. Just don't be surprised when you see people doing it, because everybody's doing it. All the young people are doing it. You know what I mean? Old people don't even fucking believe that it works. That's true. And the Chinese are just selling them. So here we go. I'm going to show you this right here. This shit right here. I bought this one in America, by the way. I bought this from a regular, like, country dude in America on eBay. And it's about 20 times bigger than the plates in here. Okay, so we take this off. Take the handles off. I'm going to take this off so you can see what's inside of it. No. So, okay. So we got that off, and then we have to take this off. This is the cover. There's nothing in it. It's just an empty cover. It's a piece of sheet metal. Okay, but the inside of it is this here. There's absolutely almost nothing in here. This is the container in which the plates are. And it has a plastic lining inside because it would corrode. It would corrode. So this is very simple. These are the two plates. There goes positive wire, negative wire. There's a fan in there in case it gets hot, but it's very, very simple. There's actually nothing to it. Oh, there's a pulse width modulator in there, but the thing is, it's not adjustable. Okay, this one is not adjustable. This is a commercial item. This just goes on and off, and I think it adjusts itself or something. But that's it. It's a pulse width modulator and a wet cell. This is actually a wet cell. This is called a wet cell because everything is inside of it. It's about the size, it's not that big. It's 4 inches in diameter, about 6 inches tall. And I've seen some people cut them open, and what's in it is a series of plates, just like that. And so I'm not sure what this, oh yeah, this is some kind of regulator. I'm not even sure what it is. Oh, it's a pressure gauge. That is a pressure gauge. This right here is a pressure gauge. Pressure gauge. you know. Anyway, so it goes through here. Anyway, so this is just the same as mine. Okay, I have also a flashback arrestor. Mine is plastic. When it goes off, it just blows in pieces. So, but the thing is, the reason it blew up before is because this right here, this flashback arrestor, is way too small. This flashback arrestor is like for this one, and I tried to use it on that one. So it was under great pressure already, but it didn't explode. It was under great pressure already, but it didn't explode until I plugged the top. And then HHO will self-ignite under very low pressure. And it was in that tank. That tank blew. That's a new tank. The other one got blew like in half. That's very thick plastic. And the explosion was so strong, it moved everybody's hair in the room. Everybody in the room felt it physically, and if it was a little bit stronger, it would have broke the fucking windows. It was a nice, strong explosion. But, so, this, let me just show you. This is the flashback arrestor. The flashback arrestor on here is very thick. It's like 3 millimeters thick. That shit, if it blows up, it will not, it can't. It's going to go back. It would just go back. It would blow off the plastic tubes. There's no way for that to blow up. But I'm using plastic stuff on mine. The one you buy from the store has metal components, stainless steel. Okay, so we're going to turn this on. And I don't know if you can see the water level. It's very low. It's almost to the point where I'm supposed to put more water in it. But I don't want to do that right now. I'm not going to do it. So it also has an amp meter on it. Okay, so we're just going to close that airtight, and it is just nothing. It's so simple. Oh, because you were telling me like, oh, they have to it's very expensive to make hydrogen. It's totally not. About $20 worth of shit, you can make endless hydrogen. So, anyway, let me get the lighter. And I might also have to get my welding windows. Okay. Yeah. Okay. So now, okay, so I'm going to show you this here. Okay, so it has a pressure gauge and an amp meter. Everything is down tight. It's kind of rickety. I got to bolt that in higher, but it's not supposed to move around. Anyway, boom, I turned it on. Right now it's going for 15 amps. 15 amps, the fan turned on. I'm letting the gas go through. Go like that. Here we go, pressure is rising. You don't want it to get too much or it will blow up. Okay, so we go like this. And get it lit. Turn it down a little bit. Damn it, I can't get it lit. Okay. Okay, there it is. It's lit. I don't know if you can see it. I don't know if you can see it. Where are we at? Where are we at? Ah, there we go. Okay. You see that little flame right there? That flame is 4,000 degrees. This flame here is 4,000 degrees. So I'm going to show you. Put on my welding glasses here, and look, this is a piece of ceramic. This is a piece of ceramic, and I already burned a hole in it before, but I'm just doing this for you. Oh, there we go. That is clay. That is ceramic material. And this is 4,000 degrees. So it turns this into granite and also melts it. Okay, so you can see it's still doing it. It's molten. I'm just putting a hole in it for you. I mean, to show you that it will. It'll melt any kind of material. Oh, shit. I went out of the thing. Anyway, that's it. Watch out, don't touch that because it's hot as freaking hell. But that's what we're working with here. That little flame is 4,000 degrees, and I can make 9 liters of that per minute. With that item over there, that makes one like 20 times this big. And so, let's see. Okay, we're going to turn it off. We turn this off. It might pop. We let it out. It didn't pop. Sometimes it back flashes, but no. Okay, so we release the pressure. Let it stop. And we close it all the way up. And that's it. That was that. Okay, so you look at this. This one didn't actually put a hole in it. It almost put a hole in it. I didn't take the time to put a hole in it. This one put a hole in it. Same torch. Anyway, so this. Oh, and the area around. Trying to get the focus to focus. Anyway, that's not wet. That is ceramic material that has been shiny. So I believe that's how they cut those stones in Egypt. Because it makes a very shiny surface. And it cuts very easily. You can get it wet and then just wipe it with a stick. You could just get it white hot and then you could poke a hole in it with just a stick. Anyway, it's very interesting. So, and it's still hot. Yep, still kind of warm. Yeah, so it has turned into granite. It turns into granite and then it cuts the granite also. So that is dead serious. That's some serious stuff there. Okay, so what's my next thing I'm doing? Something else that I'm doing is, this right here. Oh, sorry. Whoop. Okay. All this stuff right here these are graphite plates, and you see one of them is thicker than the other. So they're asymmetrical, so it will have a positive and a negative. And I guess I don't know which one would be negative. I have to test it. Anyway, so we got these like this. Okay, so 12 square inches of this is supposed to make 12 volts. A 12 by 12, 12 inch by 12 inch square of this is supposed to make 12 volts. So I believe this will probably make, with all these I have here, I have a little stack of them. I have 10. I have 5 2mm and 5 3mm. And so all these together out in you know, it's not going to be 12 inches, but it's going to be, I think I'm going to get 4 volts out of it. I expect to get 4 volts out of it, because what I do is I take this, which is polymer, same stuff than they have in the diapers. This can take like hundreds of times its weight in water or some shit. It's very absorbent. And so you mix some of this with, this is powdered graphite. It's the same stuff as this, but it's in a powder. And so this and this, you make it into a paste. And then you put it between two of these. You put the goo in between. You don't let them touch. Like you put like little spacers in there, little 1 millimeter plastic washers. You put in there. So these will be 1 millimeter apart with goo inside. And you cut off one corner of one and one corner of the other. And then you put a piece of metal there, positive and negative. Okay, so we got that. And the thing is, this item right here, this HHO right there, it's called a dry cell. This dry cell right here has 64 plates, and it can make 11. It's supposed to make 11 liters per minute, but I only need it to do 7 or 8 to run my truck. But anyway, I did it before, and I have to set it up safely. I set it up just to see if it would work, and it worked. But I have to put it in a box and put it in the car and everything like that. But that will do that with 12 volts. That does that with 12 volts. Okay? And then so the energy coming off this has a potential to go 35,000 watts. 35 kilowatts when it's all connected together. So what I'm really trying to do right now is I'm trying to manage. I can make electricity. I don't doubt that. I don't wonder or anything like that. I can do it. And I have 20 of these in series, which is a lot of fucking power. I had to put some kind of a fuse on it. Not fuse, but a limiter. I want to put a limiter. I want that to be, I don't want it to be dangerous. I'm going to find out what kind of fuse and limiter and shit I have to put on it. Because I got 2 banks of these that are 24 each. So that's a lot of power. And each bank of 24 of these will run that motor for an hour. So what you do is you put it on a timer. Every 55 minutes, it will switch over to the other bank and charge the other one. And that motor charges the bank of this in like 10 minutes. So you could actually have 1, 2, 3, 4. You could have 5 or 6 banks of these, but I'm only using 2. And that's it. There's a lot of goddamn power. Okay, and so what I'm doing with these is we're going to put this on a solid state relay or something like that. We're going to put a relay on it so that it's not putting out. It's not just putting out. This is very small, 1/2 a volt. It's not putting out 1/2 volt. It's going to be connected to a gate that lets it build up. It's just going to keep going, and it won't tap it until it reaches. I need to test it and find out full potential. But I need to find out how much it saves without being discharged. And then so this will go up to like 2 volts, and then it will release. Boom, like in a pulse. It would be a timed pulse. Right? It would either be by power or time, but it's going to be pulsed. Because I know for sure you get more electricity out of these if they're pulsed. Because what can you do with 1/2 volt? Nothing. What can you do with 2 volts? You can make hydrogen. with 12 volts, you can do heavy stuff. Anyway, so this right here is a solid state relay, I think. Yep. So I got that. Yeah. That's what I'm doing. So, actually, here's the instructions to it. Right here. So we got that. Okay. So I'm trying to think. I guess that's all it. But anyway, so I'm reading this book here. Got from my dad. But anyway, so I have full control of electricity. Not full control, but I have more control of electricity than I have before. And anyway, thanks, Dad. That's what I'm doing with all the stuff. I'm over here making a monster. I'll drive my car around with a science project in the trunk. Okay. Anyway, that was it. Happy Father's Day.